Chain rule worksheet number 1 from yesterday. Remember, the assignment was just 1 through 8. And that was just you getting used to using the chain rule and what it is and how it works. Okay? And then I had told you yesterday, I gave you one example at the end of the period, kind of where we were headed. Where we're going to still do like product rule, quotient rule, but in those product rule or quotient rules, you're going to have a chain rule. Okay? So it starts to get a little bit more complicated. The good news is, what we're going to do today, we're going to do, if you go to the back side of the worksheet, we're going to go through just numbers 9, 10, 11, and 12. We're going to do those 4 together, just as our examples basically on how these work. The more complicated part is the part where you're trying to kind of clean it up and get it into factored form, kind of the final form that you want it in. We'll talk about it, but what you're going to find out is this. I'll give you a heads up in advance. These are a little bit longer problems, which is why you're not going to have a ton of homework questions. But you also have to be very careful as you work your way through them. Okay? So make sure you're paying attention, make sure you're looking at those little details, because if you miss a little detail, it could throw some things off. Okay? So, but like I said, I'll take my time, we'll make sure we go through it so you're understanding. Okay? So if you take a look at problem number 9. On this one, is this a product rule, quotient rule? What rule are we using? This is a product rule. Yeah, you're multiplying two factors together, so this is a product rule. So let's start there. So y prime equals, okay, product rule is first function or first factor times the derivative of the second function. And so if you only focus on the second function, how do I take the derivative of that? What rule do I use? It's partially a power rule. This is the chain rule. Anytime you have a quantity raised to a power, okay, like a binomial or something raised to a power, you know it's going to be a chain rule, where you're going to work on the power first, the outside function, then we're going to work on the inside function. Okay? So we're going to need to do the chain rule with the second part here. So we're going to start with that 4th power. If we bring it out front, remember you leave the stuff in the parentheses for now, you leave it alone. That then becomes the 3rd power. Okay, so there's your derivative of the outside function. Now we multiply by the derivative of the inside function. Okay? So times, and I'll put this in parentheses, derivative of the inside is negative 8x. And that's just a power rule. So there's that's probably, when you're doing the derivative, when you're finding the derivative, that's probably the hardest part right now. Okay? Cleaning it up is a little bit more complicated. But so there's your first times the derivative of the second, plus your second factor, your second function here, times the derivative of the first function. I do not need the chain rule for the first one because that quantity is not raised to a power. You're just taking the derivative of that quantity, meaning you're just using the power rule. So derivative of 3x cubed plus 1 is 9x squared. Okay? There is the actual product rule with the chain rule involved where we went through everything. Okay? So now here's the cleanup process. Here's how we get to the final answer. This is where it gets a little bit messy, where you got to take your time and make sure you're looking at the details. First thing I'm going to guide you on is this. What you need to see when you look at where we're at right now is that all of this stuff is multiplied together. That's one term. There's no plus signs or anything. These are all factors multiplied together. Then you get to a plus sign. That's the second term. You have to see those as 2 separate terms. Okay? And you'll see why in a second. We'll get to that. For now, what I'm going to do, there's not a lot of cleanup that we can do at this point. But for now, what I'm going to do, I'm going to leave this first factor alone. I'm not going to touch that yet. I'm going to leave the second factor alone, the part that's cubed. Okay, so I'm going to put that next. Negative 4x squared minus 3 cubed. And then the other stuff that's there, I'm going to just multiply that and put that together. So we end up with our third factor being negative 32x. Okay, so all I did really was take the 4 times that negative 8x. That's really all I did at this point. And we have a plus sign, and there's really not much we can do at all on the second part. Okay, so I'm going to leave that alone. I'm not even going to do anything with it. Okay, here's where we now are going to put this into factored form. So again, you have to see this as one whole thing. You have to see that as the other. So here's where we go. So, and the reason, let me preface this by saying, the reason we want our answers in factored form is because if you do go on and you take calculus next year, whether it's in high school, whether it's in college, when you get to calculus, eventually you take derivatives and you set them equal to 0 and you start solving. It's a lot easier to solve if it's in factored form because then you can use your zero product property. So we're not going to do that this year, but when you get into calculus, that's what will be done, so we're trying to set that up from the beginning, okay? So here's the idea. Here's the process that we're going to do. Y prime. We are going to we're looking for greatest common factors. That's what we're going to look at. So if you look in the first part, I'm going to start with the simplest one, the negative 32x and the 9x squared. What do those two factors have in common? Just an x. Okay, there's no other numbers, there's nothing else there that you have in common. So that's the first thing I'm going to factor out. I'm going to put an x down. Okay? And we'll come back to this. I'm just finding the factors first. What else do those two terms have in common? The negative 4x squared minus 3, this one's got 3 of those factors, that one's got 4, which means they both have at least 3 in common. So we're going to factor out negative 4x squared minus 3 to the third power. By the way, on your worksheet on the answer key, there's a typo. It's wrong. It should say to the third power, not to the second power. Just a heads up on that. So when you look at the answer key on this worksheet, it says squared. It should be cubed. Okay? And then if we take a look, there is no other 3x cubed plus 1. There's no factor to go with it. So we're going to leave that alone. So these are the things that the two terms have in common. So now I'm going to put a bracket here just to kind of signify that this is the part I'm going to work on now. Okay, just to kind of keep things organized. So in this whole first quantity, we didn't do anything with the 3x cubed plus 1, so I'm going to bring that down. If you move over to the next quantity, notice we factored out that entire factor cubed. So that's no longer there. Then on the last quantity, we took the x out, meaning the negative 32 is still here. Okay? And we will distribute that in a second. We'll get to that. Let me stop for a second. You with me so far? You doing okay? You can see why you have to be careful and why you need to take your time, because you got to really think these through. Yeah?
So it doesn't have to come out of like every term. So you pulled out like an x and it doesn't have to come out of each separate one. It just have to come out like either side of the plus sign.
Right, exactly. As long as it can come on either side, because really what I have underlined, this whole thing is really one term because it's all multiplied together. So as long as it's, on either side of the plus or the minus sign, you can factor it out. All right, let's go to the next part. So we've got this taken care of. Now we come over here, plus, and we take a look at what did I take out, what did we factor out, and therefore what's left. Well, this first factor, we took out 3 of those, which means there's still 1 left. So we still have negative 4x squared minus 3 to the first power, if you will. And then this 9x squared, we took out an x. We didn't take any numbers out, we just took an x out, so there's still a 9x in that spot. And again, the reason I put brackets in there is that now is our focus on to finish this problem off. We just need to work on what's in the brackets. We've already factored out this stuff. So now we take the negative 32 and distribute. We take the 9x and distribute. and then we'll combine like terms. We'll clean up all that stuff in the brackets. Now we just do the algebra. Okay. So let's move to that next. When we distribute, we get negative 96x cubed minus 32. When we distribute the 9x, we get negative, that should be a negative, negative 36x cubed, and then minus 27x. Okay, just distributing into both of those parentheses.
What was that, -32?
This is just minus 32, and then I made a mistake, and then minus 36x cubed. And our final answer here now, all we have to do now is just combine, we just need to clean up that stuff in the brackets, okay? So, y prime is x times negative 4x squared minus 3 cubed. I'm going to now turn this back into a parenthesis because now it will be a factor. And we just combine like terms. If you put the x cubes together, you should get a negative 132. You then have a minus 27x that I can't do anything with, and you have a minus 32 I can't do anything with. And there is your derivative. Okay? Like I said, the only thing on the answer key, the only difference between what you would see on the answer key is it said squared instead of cubed. It's just a typo. It should be cubed. Okay? Like I said, it's a lot. Okay? But here's the good news, like I said. As you work your way forward, today I'm kind of working through the process so that you're starting to understand at least what to do. Tomorrow, I'm going to give you an assignment today that's 8 questions total. Some of it is just chain rule problems. It's not all of this. A little bit of it's review. So it's only 8 questions total. You'll have tomorrow to work on that, and then I'm going to give you only one more assignment for this week that you'll have the rest of the period tomorrow and still Thursday to work on as well. Okay, so I'm going to give you time to work your way through the process. And then next week will be review. Okay. Let me stop. Any questions on this? Because like I said, it is complicated. It is in depth. All right, let's go to the next one. Let's take a look at problem number 10. This one is a quotient rule. Good. Okay. So, we do have to do the quotient rule, where most of our focus will be the numerator. It'll be kind of similar to what we just did. But let's start with our quotient rule to begin with. Y prime equals, remember that quotient rule we said it's low d high, meaning you start with the denominator. So 3x to the 4th minus 2, there's the low, times the derivative of the numerator. That's the d high of the low d high. Times. And now we have to use the chain rule to find the derivative of the top. Okay? So, we bring the 5 out front. It is now raised to the 4th power. And then remember, we multiply by the derivative of the inside function, which would be 3x squared. Okay? So there's the low d high. Here's the low. Derivative of the numerator. It is minus now. Yep. Minus high d low, meaning numerator. Times the derivative of the denominator, which this is not a chain rule because it's not a quantity. This one would be 12x to the 3rd. All over. Remember the final part of it? All over the square of what's below, meaning just the square of whatever's in the denominator. So there's the setup. Now the good news, like I said, whenever you do the quotient rule, just ignore the denominator for now. Just focus on the numerator. and we'll just put the denominator at the end. Okay, you don't have to do anything with it. Guys in the back, focus please. So if we start taking a look at just the numerator, that's what I'm going to focus on here for a couple steps. I'll put the denominator back at the end. If we just focus on this, let's go to y prime again. And once again, everything to the left of the minus sign is all one term. It's all multiplied together. And then everything to the right is also one term. So if you start looking at what can I factor out, okay, I'm going to start with the simpler things first, and then we'll go more complex. Notice you have a 3x squared, and you've got a 12x cubed, which means I can take the 3 out, and I can take an x squared out. Okay? So I'm gonna pull out a 3x squared out of those factors. Okay. Then if we look, you also have an x cubed plus 4 in both parts, and you've got at least 4 of them, which I can factor out. So the other thing I'm going to factor out is the x cubed plus 4 to the 4th power. Okay, bless you. That's it. That's all we have in common. There's our greatest common factors that we can pull out. So now, once again, here come the brackets. And we start writing down kind of what's left, and we just focus on what's in the brackets. So if we take a look, let's just start at the beginning. I didn't do anything with the 3x to the 4th minus 2. I haven't done anything with that, so I'm going to leave that there. I am going to go through and do a couple things at once. Because if you notice, I didn't do anything with that, nor did I do anything with the 5. I took the entire x cubed plus 4 out, and I took the 3x squared out, which means I say I'm going to do 2 and 1. I'm going to take that 5 and distribute it, so I don't have to do it another step later. So we have 15x to the 4th minus 10. Okay, so there's the first part. There's everything up to the minus sign. Now we have minus, and we will take a look. We took 4 out of the 5 of those out. We factored out 4 out of 5, which means there's one of those factors left. So we still have x cubed plus 4. And, we will, but the 12x cubed, remember we took a 3 out, and we took an x squared out, which means there's a 4x left. Okay. And now we're right back to where we were, yep. We're going to take the 4x and distribute. The other part is, don't forget the minus sign out front also needs to get distributed. Okay, so you're not just distributing the 4x, you're distributing the minus sign too. All right, let's take a look. So we have y prime equal to 3x squared. When we distribute, we'll get 4x to the 4th, but then again we distribute the negative, so it becomes negative. Negative 4x to the 4th. Distribute times 4, we get 16x, but again, distribute the negative, so it's negative 16x. And here comes our final answer. If we just clean this up as factors, we have 3x squared, the quantity x cubed plus 4 raised to the 4th power, and now when I combine like terms, we end up with 11x to the 4th. There's nothing we can do with the minus 16x. There's nothing we can do with the minus 10. And now here is where I'm going to put the denominator back. Remember we said we had the quotient rule, so it was over the denominator squared. Now I'm just going to put that back in the denominator. I'm not going to do anything with it. It's just part of the problem. So we have 3x to the 4th. What was it, minus 2? Yeah. And there is your derivative. Okay? See what I'm saying about how you have to really take your time and be careful and Do not rush these problems, okay? You can do these. I know you can. They're hard, but you can do these. You just have to take your time, and you just have to practice your way through it, okay? Let's take a look at the next one. It looks bad. It's actually probably the easiest one out of the four we're going to do today. It looks probably maybe the worst. It turns out that it's probably the easiest. Here's why I say that. When you look at this one, product rule, quotient rule, chain rule, what am I doing here? How do I do this one? How do I find the derivative?
Chain.
Yeah, this is just a chain rule problem is all this is. This is not a product rule. This is not a quotient rule. This is just a messy chain rule. So let's do it as such. Let's start on the outside.
Are we gonna put this in the test?
We haven't made the test yet, to be honest. But I guarantee you'll have something on here like this, yes. I don't know how many of these, but we haven't made it yet. Okay? So I don't know how many we're going to put on there. I would have not imagined that there's going to be like a ton of these, but yeah, maybe. Something like that.
Maybe one.
Maybe, I don't know. All right, so let's do a chain rule. We start on the outside function, the fourth power. We bring it out front. So we end up with 4. Leave the stuff inside all alone. So now it's cubed. Times the derivative of the inside, which turns out it's actually another chain rule inside as well. Okay? All you're doing is bringing the 4 out front. You're just doing a power rule. 4 came out front, and now it's raised to the third power. Now we do the derivative of the inside, which the derivative really we have another quantity raised to a power, so we do another chain rule. Bring the 5 out front. X plus 5 to the fourth power. And technically we got one last thing. It's not going to affect anything, but times the derivative of the inside. What's the derivative of the inside? 1. Derivative of x plus 5 is 1. There's your chain rule. You took care of the fourth power first, then you took care of the fifth power, then you took care of the x plus 5. So it kind of turned out to be like 3 parts to it. I say this is actually the easiest one because if you look, really the only thing you're going to deal with is the 4, the 5, and the 1. Just move it to the front, call it 20, and you're done. Y prime equals 20. There's nothing else that we need to worry about on this one. Okay. So this one turned out to be a chain rule. Not a ton of work to do on this one because we didn't have a product rule or a quotient rule that we had to kind of work our way through. All right, let's finish up one last one. Let's take a look at number 12. Only because you got one that has, in this case, a fourth root. Okay? And what do we do in that case? There's couple parts we got to talk about. All right, so we take a look. Number one thing, I talked about this yesterday. Anytime you see a derivative problem that has a root in it, rewrite it before you even start trying to work on the derivative as a power instead. So first thing I'm going to do on this problem is rewrite this. Instead of the fourth root, I'm going to take that as the 1/4 power. Okay? So we have negative 4x to the 5th minus 3 raised to the 1/4 power. Which means, what kind of problem is this one? How do we do the derivative? Which rule? This now is a product rule. You're multiplying these two things together. So it's kind of like the first one that we did, like number 9. So if we take a look, let's start with our product rule. Okay? Y prime equals first factor times the derivative of the second factor. Because it's a quantity raised to a power, here's where the chain rule comes in. Bring the 1/4 out front. What power will that go to now? We talked about this yesterday. I want to just read. Negative 3/4. Remember, we're not switching the sign from positive to negative. We're subtracting 1 from the exponent. 1/4 minus 1 is negative 3/4. Okay? So there's the power rule. There's bringing that out front, times the derivative of the inside, which is negative 20x to the 4th. Plus the second function, the second factor that we have here, a negative 4x to the 5th minus 3 raised to the 1/4 power times the derivative of the first one, which in this case, again, is another chain rule. Okay? Turns out to be messy again. Not as messy because we don't have the fractions, but it's another chain rule one. I'm going to put that just down below because I'm running out of space here. We bring the 5 out front. We've got 5x cubed minus 3. Now to the 4th power times the derivative of the inside function, okay, which is what? 15x squared. All right. It's a lot. There's a lot going on there.
Yeah.
Okay? There's a lot going on there, that's for sure. Like I said, there's a reason you're not going to have like 25 questions for your homework. You've got 8 to do over the next couple of days, and not all 8 of them are like this. Some of them are easier than this in terms of just chain rule, just some more practice. Okay? You will have some that are a little bit messy, but all right, let's take a look. So now again, all of this stuff, that's one term, and all of this stuff is your second term. Okay? Just because this is pretty messy, let's clean this up a little bit. Let's actually clean this one up in terms of factors before we start doing greatest common factor. Let's try to help ourselves. Y prime. So for the first part, I'm going to just write it as 3 factors here. If we have 5x cubed minus 3 to the 5th power, we'll leave that alone for now. We've got this next one to the negative 3/4. I'm going to put that in there. And then I'm going to just take the 1/4 times the negative 20x to the 4th. Just put those two together, multiply that, and we will get negative 5x to the 4th. Okay? So there's your entire first term right there. Okay? Cleaned up a little bit. Same idea with the second one if we clean up that part of it. Again, I'm going to write the first factor, the 1/4, leave that alone. I'm going to leave the second factor alone, the one that's raised to the 4th power. Let's put that down. And then just like we did on the first part, I'm going to take that random 5 and multiply it by the 15x squared. Put those two together. So we get 75x squared. All right, so there's your 2 terms right there. All right, now we start looking for greatest common factors that I can start to pull out and clean this whole thing up. So y prime equals, if we take a look, what's the first common factor that we have here? Okay. 5x cubed minus 3. How many of those can I pull out? 4. You got at least 4 of them in each part. So let's take 5x cubed minus 3, that quantity to the 4th power. We can pull those out. Okay? I'm going to also, matter of fact, I should have done this first. I'm going to start with it doesn't really matter the order to be honest, but I'm going to actually start with the very first part, the easiest factor. What do I have in common between negative 5x to the 4th and 75x squared? 5x squared. Let's pull that out too. Okay, I'm actually going to put that at the beginning. Let me get rid of that. I'm going to put that 5x squared here. Okay, so we took the 2 parts out. Now, here's the last. I saved this for last because I want I want to make sure you understand this one. It's a little bit complicated to understand, but we'll get you there. I do still have the negative 4x to the 5th minus 3, but if you notice, one's raised to the negative 3/4, one's raised to the positive 1/4. I'm going to factor out the one with the negative 3/4, and I'll show you why in a second, how that affects things. So if we take out negative 4x to the 5th minus 3 raised to the negative 3/4 power. Again, I'll show you the effect on that in a second. Okay? On how that affects the one that raised to the 1/4. Okay? All right. So there's our common factors, which means now here come the brackets, and we just figure out what do I have left. What still did we leave behind? So remember we took 4 of these 5 factors out, so I still have a 5x cubed minus 3. That's still there. We took out the next factor completely, so that's not there. And we took out a 5x squared, which means there's still a negative x squared there. Plus, all right, we took out, and actually I'll do the easy ones first, and I'll leave the last one, just so you're understanding. In this case, out of the 75x squared, we took out 5x squared, which means there's just a 15 left behind. Okay, so there is a 15 that's here. We took out all of the 5x cubed minus 3s. We took all 4 of those and factored those out, so that's gone. And here's the last part. Okay, I'm going to put down the negative 4x to the 5th minus 3, and we'll talk about what power that's raised to. Let me go to the whiteboard here for a second. Think back to like your rules of exponents, to make this make sense. Okay, if I asked you what x squared times x cubed is, what's the answer? X to the 5th. You get x to the 5th, which means what's the property? When you have the same bases and you're multiplying, you add the exponents, right? So here's kind of how this works here. What we took out, I'm just going to call the base on the whiteboard. I'm just going to call the base x because it doesn't really matter what the base is. We're just focused on the exponent. So if I have an x to the negative 3/4, and we're trying to figure out what am I going to multiply that by, okay, when I factor it out, remember that's what you're doing is that times something will get you back to what you had. What goes in that spot right there, that blank? What power? Negative 3/4 plus what gets you to 1/4? 1. Didn't we subtract 1/4 minus 1 gave me negative 3/4, right? So when I factored out this x, this whole quantity to the negative 3/4, what it left behind is an exponent of 1, which actually turns out to be nice. It's kind of a nice surprise. Okay? So this quantity right here, when I factored out the negative 3/4, there's really just a 1 sitting right there. Okay? So it kind of cleans it up a little bit. Okay? That will always happen. That's why I wanted you to see that. If it was a negative 2/3 that you were pulling out, it'll end up with x to the 1st power. Okay? It'll always end up with whatever that quantity is to the 1st power. Okay? And now the rest of this actually isn't too bad. You've done all the hard stuff. We've got y prime equal to 5x squared. We have the quantity 5x cubed minus 3 raised to the 4th power. You've got the negative 4x to the 5th minus 3 raised to the negative 3/4 power. And now, just like you've done on previous problems, distribute the negative x squared, distribute the 15, and then just combine your like terms, whatever you end up with. Okay? And what you should have is what? What do we end up with? When you do that stuff in the brackets, when you do the distributing and combining of like terms, you end up with negative 65x to the 5th (3x squared and a negative 45. Okay, that's ultimately what you come up with when you do the algebra in the brackets of distributing and combining like terms. Okay. It's hard. It's also the last lesson for seniors. That was it. Okay, that was it. And now the next 2 days is let's slowly practice this. Let's work our way through and practice and work and see what we can come up with and make sure that you're understanding why we do certain things in different scenarios and working through that process. Next week, like I said, it's a 5-day week. Friday's your test, and you got basically 4 days to work through a whole bunch of just review problems of product rule, quotient rule, chain rule, all of these types of things. Okay? Let me give you the assignment. You've got about 10-ish, a little more than 10 minutes left. Again, the first ones are just review. They're not these super complicated ones.
I actually have like 6 minutes.